In this video, we will discuss about the basic concepts of linear discriminant analysis, working steps of LDA, advantage, disadvantages, and uses of LDA. Next, we discuss about the basic concepts of LDA. LDA is a supervised learning technique that can be used for both classification and dimensionality reduction. It focuses on projecting the features in higher dimension space onto a lower dimensional space, minimizing computational and overfitting costs. For example, it converts two-dimensional space to one-dimensional space or three-dimensional space to two-dimensional space. It aims to classify objects into one of two or more groups or classes based on some set of parameters that describes objects. The diagram shows the classification of different classes before and after implementing linear discriminant analysis. LDA does this by maximizing the distance between the means of different classes while minimizing the variance within each class. The process involves calculating eigenvalues and eigenvectors on the scatter matrices of the classes, and then transforming the features into a lower dimensional space for classification. The following steps explains the working of LDA. In step 1, calculate the mean vectors for each class in the data set. Then in step 2, find distance between the mean of different classes, known as between-class variance. In step 3, find the distance among the mean and sample of each class, known as within-class variance. Then in step 4, compute the eigenvectors and corresponding eigenvalues for the class variance matrix. Then in step 5, sort the discriminant vectors by their corresponding eigenvalues in descending order. The green shows the eigenvector. Then in step 6, reduce the dimension by selecting the top discriminant vectors. In step 7, project the data into the new subspace formed by the selected discriminant vectors with certain threshold value. In step 8, perform classification using a simple decision boundary. Next, we can see the applications of LDA. In face recognition, LDA helps to extract the most distinguishing facial features, improving recognition accuracy. By reducing the dimensionality of facial data, LDA simplifies the task of matching faces to individuals, making it valuable for security and authentication. In medical diagnosis, LDA helps in developing models for disease classification based on patient data. For instance, LDA can assist in diagnosing diseases like diabetes by analyzing factors such as blood sugar levels, weight, and age. In text classification, LDA is employed for text classification tasks. It helps in categorizing the documents, such as news articles, customer reviews, or emails, into relevant topics or sentiments. This is also used in information retrieval, recommendation systems, and sentiment analysis. It is also used in marketing and earth science. The advantages of LDA are as follows. First, dimensionality reduction with class separation. LDA aims to maximize the separation between classes while reducing the dimensionality of the data. Second, it utilizes class information, that is, LDA takes advantage of class labels during its computation, which can lead to better separation of classes compared to unsupervised techniques like principal component analysis, PCA. Third, works well for small sample sizes. LDA can handle situations where the number of samples is small compared to the number of features. Fourth, for data visualization, the reduced dimensional space generated by LDA can be visualized, making it easier to observe the separation between classes and the distribution of data points. The disadvantages of LDA are as follows. First, LDA will fail when the discriminatory information is not in the mean but rather in the variance of the data. Second, if class labels are ambiguous or if the classes are not well defined, LDA might not perform optimally. Third, LDA's linear nature might not capture complex decision boundaries that nonlinear techniques like support vector machines or neural networks can handle. Fourth, when the number of features is much larger than the number of samples, LDA can be prone to overfitting. Thank you for watching this video. If you like this video, subscribe this channel and press the bell button.